All right, good morning, guys. I'm sorry for not being at school today. I thought that I would just record a lesson that you can watch while you are in class or perhaps over the weekend if you don't have Wi-Fi in class or something. I will post this recording to the zero-rated server as well, which hopefully will stay operational. But yeah, like I said yesterday, we do have to move on to hyperbolas. Also, sorry about my voice. I am quite sick, so my voice might come and go throughout the course of this video. All right, if you guys can just copy down this note, I'm going to read through it and explain various things, fill various things in as we go along, and then I'm going to draw an example of a hyperbola as well. So in grade 10, you learned this standard form of the hyperbola, which is just y equals a over x plus q. Now, sorry, a, like we can see here, stays the same in grade 11. If your a value is positive, then your hyperbola will be in quadrants 1 and 3. But remember that if your graph is shifting up or down, and that is what Q does. So if the graph shifts up, for example, then your quadrants 1 and 3 also actually shift up in a sense. You'll see when we're drawing a graph, but it will basically be top right and bottom left if A is positive. If A is negative, it will be in quadrants 2 and 3, or as your asymptotes are shifting, as your graph is shifting, your quadrants are also shifting in a sense. So if A is negative, the hyperbola will be in top left and bottom right. But when you're calculating points, you will see that as well. So it's not terribly important that you memorize that. Now in grade 11, just like when we did parabolas, we are now introducing a sideways shift, a horizontal shift as well in grade 11 with hyperbolas. So now the standard form is not massively different. And the nice thing about a hyperbola is that it only has this one standard form. It's not like with parabolas where we had to have the 3 different forms and we had to work from one form to the other. With hyperbolas, this is the only form that we are working with. So it's y equals a over x minus p plus q. Q is still the shift up or down, and q is still going to give you the equation of one of your asymptotes. We'll write that down now. But now the x minus p, just like when we did horizontal shifts with trig graphs and with parabolas, if you have an x minus 1, you are going to shift 1 unit to the right. If you have an x plus 1, you're going to shift 1 unit to the left. So just like with the other graphs that we've done so far, the sign in your equation is opposite to the direction of the shift. Right, so now when we are drawing a hyperbola, there are various things that we need to find in order to draw the hyperbola. So the first thing is your asymptotes. Now, with hyperbolas in grade 10, you only had one type of asymptote, and that was the Q asymptote. That was your Y asymptote. That was your horizontal asymptote. Your vertical asymptote was always the Y-axis. But now in grade 11, because our graph is also shifting to the left or the right, the vertical asymptote is not always going to be the Y-axis. It can actually be another vertical line. So our vertical asymptote is now given by the denominator. The vertical asymptote is always x equals p. Sorry guys, the app malfunctioned, so I had to just pause there. All right, so as I was saying, the vertical asymptote is your x asymptote. Vertical, remember, is a line that looks like this. It's vertical, so it cuts your x-axis, and it will cut your x-axis at your p value. The horizontal asymptote is just like you learned last year, y equals q. To get your y-intercept, you are going to have to make x equal to 0. Right, so if you have your equation, you're going to have a over 0 minus p plus q, and that will give you your y-intercept. To get your x-intercept, you're going to have to make y equal to 0 and then solve for x, which is a bit of a longer process, but we'll do an example, then you can see. All right, now the axes of symmetry. When you have a hyperbola, there are actually always two axes of symmetry. They are both straight lines, but the one has a positive gradient and the other one has a negative gradient. If we can just look at this little rough diagram here, you will have one axis of symmetry running through there, right? And in that case, it would probably be, yeah, it would be y equals x, y equals positive x. Y equals positive x has a positive gradient. Remember, a straight line with a positive gradient is increasing, it's going up. All right, so that is one axis of symmetry, because if you were to actually take your page and if you had drawn this hyperbola and you folded it over that line, that half of the hyperbola should fit perfectly on top of that half. But then that's not actually the only axis of symmetry. If you have the line y equals negative x going through there, that line will actually also cut your hyperbola in half, because if you now take your graph and you fold it over that line, that part, or those parts rather, of the halves will fit perfectly on those parts of the halves. So with the hyperbola, you have two axes of symmetry. In grade 10, it was very simple. It was just y equals x plus q and y equals negative x plus q. Now in grade 11, because we've introduced a left or right shift, the axes of symmetry equations are a bit more complicated, but if you memorize these, it's quite easy to use. You're just going to say y is equal to, so for your positive gradient one, just the denominator, x minus p. Literally exactly like that. You don't have to put brackets there for that one. If you don't want to, that's fine. So y equals x minus p plus q. And then you simplify. That will give you the equation of your positive axis of symmetry. For your negative axis of symmetry, you're going to say y equals negative your whole denominator. So for that one, you do need the brackets and then plus q. All right. If I'm going too fast, then so if I'm going too fast, then you must just pause and then yeah, I am going to pause recording again quickly, but if I'm going too fast at any point, you can just pause and then copy down from there. Okay, we're going to do some examples now. The first one is where we are just going to draw a hyperbola. So just draw the graph. Of y equals 4 over x minus 2 plus 3. All right, just like with any graph, we have to show the intercepts of the axes, we have to show our asymptotes. And if at any point, remember hyperbola has two parts, if at any point you only have points on the one part, then you're going to have to choose x values on the other part, sub them in so that you can at least have a point on the other part. Okay, so the first thing that I always write down when I'm doing a hyperbola is I look for my asymptote. Oh, sorry that I'm yawning the whole time. I'm really feeling quite ill. All right, so the vertical asymptote is your x-asymptote. Remember, vertical line looks like this, so it will cut the x-axis because your x-axis runs like this. And just like we said before, this hyperbola is going to have a shift of 2 units to the right, which means that the y-axis, which was the original vertical asymptote, also actually shifts 2 units to the right, making our new vertical asymptote x equals 2. All right, so the vertical asymptote is always x equals this number with a different sign, with the opposite sign. Your horizontal asymptote is y equals 3. All right, that one is easy. It's always just y equals whatever that number is. So just like when we did the turning point, for example, with parabolas, the x1 changes its sign, the y1 stays the same. That's our two asymptotes. Let's find the y-intercept. So for that, we are going to make x equal to 0. So y is 4 over 0 minus 2 plus 3. And this obviously you can just do on the calculator. I'm just writing it out because this is the first example. So we have 4 over -2, which is 4 divided by -2 is -2 plus 2, which is 0. Is that right? Oh, I wrote this wrong. Sorry, that should actually be a 3, which will make this point, that value 1. My apologies. Do you see it was a +3? I wrote +2. Okay, so it should be 4 over 0 minus 2 plus 3. Okay, so -2 plus 3 is then 1. So our y-intercept is the point 0, 1. Okay, for the x-intercept, you have to make y equal to 0. So you're going to make your whole equation equal to 0. So you can decide which way around you want to write this. Okay, so there I'm just making y equal to 0. Now I'm just going to move that +3 over. It will become -3 equals 4 over x minus 2. Now, because my x is in the denominator, I need to multiply it out on the other side. So I'm going to do this. Now, guys, instead of multiplying this -3 into the bracket, which, I mean, it would be fine. Oh, sorry, I'm so sorry. Instead of doing that, I'm actually just going to move this -3 over because on the left-hand side here, I am multiplying my bracket by -3. So if I want to move that, I have to divide by -3. What would happen if you were to multiply this -3 into the bracket is you would get -3 plus 6, which you could then move the 6 over, but then you would have to divide by the -3 again. It's fine if you want to do it like that. There's no problem. I'm just going to show you the other way. I'm going to leave my bracket on that side, and I'm going to divide 4 by -3. And now to get x on its own, I have to add 2. All right, so x is then -4/3 plus 2, which I suppose I should be able to do that in my head. Let's think. That's -1 1/3, and then you add 2 to it, so that's going to get you 2/3, I think. Let me just double check because my mind is a bit fuzzy. Yes, that will give you 2/3. All right, so x is 2/3. So your x-intercept is 2/3 and 0. Okay, so now we have 4 things here that we are going to indicate on our graph. We have 2 asymptotes, which we are going to show using dotted lines. We have a y-intercept and we have an x-intercept. And we might need to find other points. So I suggest that you actually now go and you plot everything that you have, and then you figure out whether you have to actually again, whether you have to sub in other x values. All right, so let's do this. I am just going to go, because I see that my horizontal asymptote is at y equals 3. So I am going to have to draw something above that. So let's go to 5. Maybe let's just do to 6 just in case. And then I'm going to go like 4 down. Not really going to need as much space at the bottom there. Because we have no values with negative y values, no points, I mean, with negative y values. And then I'm just going to go to -4 and +4. Okay, just extend it a bit. Okay, I have y and x and 0. All right, first thing that you always want to draw is your asymptotes, because where your asymptotes are will actually, what's the word that I'm looking for? Affect how you are drawing your graph. So for x equals 2, you're going to go to the x-axis to 2, and you're going to draw a dotted line going straight up from there. So this asymptote has to be parallel to the y-axis. Okay, so it's just a vertical line like that. You see it's the vertical asymptote, so it's a vertical line, at x equals 2. You have to label it, all right? You're not going to get marks for it if you didn't label it, unfortunately. Then the other one, the horizontal asymptote, is y equals 3. So we go to our y-axis, 1, 2, 3, and we draw that there. Again, we are just using a dotted line. And again, we write y equals 3. Now, guys, in the past, in matric finals, they used to give 1 mark for each of these. And I see in last year's paper, they actually gave 1 mark for both of them. So for plotting both the x and the y asymptotes correctly. Sorry. Yeah. And for labeling them, it was just 1 mark. Okay, now let's plot our y-intercept. 0, 1. So add 1 on the y-axis. Our x-intercept is at 2 over 3. So that's 0, that's 1. So 2 over 3 will kind of be there. Now, guys, this is what I was talking about earlier. We know that a hyperbola has to have 2 parts. So obviously our one part is going to be over here in this quadrant. And do you see that it's not really a quadrant? The quadrant actually has shifted. Now the quadrants are actually, this is kind of the new third quadrant in a sense, because the asymptotes are actually shifting the axes in a way. All right, but we know that the one part has to be here. And then we need another part over here, but we don't have any points on this part. Now, guys, you do need to calculate at least 1 point. And the way that you're going to do that is if this is x equals 2, then obviously any x value bigger than 2 will have a point in this part of the graph. So let's sub in x equals 3, for example. Let's take our calculator. We're going to take the graph. We're going to type 4 over x minus 2. So now 3 minus 2 plus 3. And we get, oh, now that's too big. We get a y value of 7. All right, so if I wanted to plot that point, I would have a point at 3 and 7. I'm going to try 4 actually, because that will give me a smaller point, just because my y-axis only went up to 6. But if you had a longer y-axis, you could definitely plot that point. That would be fine. I'm going to try an x value of 4, and that gives me a y value of 5. All right, so you're subbing in x equals 4, any number that's bigger than 2, and you're getting y equals 5. Okay, so when x is 4, then y must be 5. Now this is y equals 3, so y must be 5. So that is the point that we are plotting. All right, and I am just going to turn my page. And now when you are drawing your graph, this top one is a bit awkward now because we don't really have a lot of space, but you do want to draw the graph so that you can see that it is kind of heading towards the asymptotes. All right, it's a bit difficult because, like I said, we don't have a lot of space there. For this bottom one, we can do a bit of a better job. So now we can draw it like that, going towards the asymptote and downwards also towards the asymptote. Okay, we just need to, label these points. So this was the point 4, 5. This is the point 0, 1, and this is the point 2 over 3 and 0. Okay, and that is what you need to do when you are drawing a hyperbola. Let's just make a little note here for that point. Sub in x equals 4, then y was equal to 5. Okay, that's how we got that point. And like I said, when we were doing parabolas, you could sub in any x value there as long as it is bigger than 2. If you think that 1 point is not enough, you can always sub in another one, and that will give you a clearer shape. But yeah, you can decide that you only actually need 1 point. Okay, I want you, let me just see what's the time. Yeah, so I want you guys to practice some of these hyperbolas, drawing them on your own. So your homework for Monday is going to be to draw these hyperbolas. I'll write them down. So exercise 7. The numbering in exercise 7 is very strange, so I will write down the number, but then I'll also write down the actual equation so that you have them all on here in case you don't have your textbooks at school. So exercise 7, page 97, I want you guys to do number 1, which is asking you to draw the graph of f of x, which is 1 over x plus 2 minus 3. Then number 4 is asking for the graph r of x, which is negative 4 over x minus 3 minus 1. Now, guys, this negative is going to go with the 4. All right, so in actual fact here, your a value is negative. If the negative is in front, you're not going to put the negative with your x at the bottom. You're going to put it with the numerator. So this is the same as negative 4 over x minus 3 minus 1. And then I want you to do number 7, which is wx equal to negative 3 over x minus 1 plus 2. Okay, so you are drawing those 3 graphs for homework. So what you're going to do is you're going to write down the asymptotes like we did. You're going to find the y-intercept. You're going to find the x-intercept. Then you are going to plot all of the things that you found. Then you're going to figure out, do you have enough points to actually draw the graph? If not, you're going to have to choose x values in the section of the graph that you need points, and then that will give you the y values so that you can have an x and a y value together. Now, I actually just quickly want to go back to this example because we haven't discussed finding the axes of symmetry, just in case. But guys, the axes of symmetry, you only find them if you are explicitly asked to find them. So here they would have had to state specifically find the axis of symmetry as well. Now, I'll just write it here at the bottom. So AOS, just for short. So you're going to have the first one, which is just going to be y equals your denominator plus 3. So x minus 2 plus 3. And then if you simplify that, that is the graph y equals x. Negative 2 plus 3 is plus 1. Okay, so the straight line y equals x plus 1 is one of your axes of symmetry. And guys, if you had to draw that, remember that the constant term in the straight line equation is the y-intercept. So it will cut through the y-intercept there of 0, 1. And then your axis of symmetry is always going to go through the point where the two asymptotes cross. So I'll draw it in here just for this one. Maybe I'll use my Koki for this. All right, so that is going to be your one axis of symmetry if they asked you to draw it. If not, then don't even worry about it. They usually don't ask you to draw it. They might ask you to find the equations of it, but usually you are not expected to draw these. Okay, so that would be the one axis of symmetry. That would be y equals x plus 1. So it has a y-intercept of 1, and it is going to go through the points where the two asymptotes cut. The other axis of symmetry is going to be y equals negative your denominator plus 3. So let's see, if we multiply that out, you'll get negative x. This will give you negative times a negative. This will give you positive 2 plus 3 is then plus 5. So that is the second axis of symmetry. Now, if it's negative x plus 5, then it's going to cut through the y-axis at 5. The y-intercept of this line is 5. That's 1, 2, 3, 4, 5. So it's going to have a point there. And again, it is going to go through the point where the two asymptotes cross. So that will be the second axis of symmetry. Okay, I'm just going to extend it a bit there so that you can see. All right, so that would be the second one. And guys, if they are asking you to draw these, you do have to also label them with their equations. Otherwise, you won't get marks for that. So y equals x plus 1 is the one with a positive gradient. Y equals negative x plus 5 is the one with a negative gradient. All right, for these ones, for these questions, they are saying, state the equations of the asymptotes, find the equations of the axes of symmetry, find the coordinates of the x-intercept, y-intercept, and then you're going to draw it. All of those things. All right. So for this one, you want the asymptotes. They want the x-intercept. They want the y-intercept. And they want the axes of symmetry. Right. So for these three, let's practice everything properly. And then if they ask it in a simpler way in a test or exam, then we know that we have covered all the bases. All right. Thank you, guys. You can work on that now. We will discuss this on Monday, but I'm not going to reteach this stuff on Monday, please. Thank you. Have a good weekend.